Hey, good morning, everybody. How's everyone doing today? Today's kind of review day, getting ready for tomorrow's test. So I want to cover a couple of items. Um, First of all, I think it was on Monday, I gave you some data and an intro to a lab called the Lead Lines Lab. And the first item on your homework turn in for tomorrow should be the summary for that Lead Lines Lab, interpreting that graph. Okay? So if you remember, that graph looked something like this. We had resistance here, we had length here. Okay? Then we had three lines, and they weren't perfectly straight. We can get into that detail later if you want to, but they all had a kind of a shape like this. This one ended up being your 6 millimeter one. This one was your 4 millimeter line, and the red one was your 2 millimeter line. So what does that tell you in terms of a relationship between resistance and length, or resistance and thickness? Well, first of all, resistance and length is a pretty easy one. As it got longer and longer, from 0 centimeters to 10 centimeters, the resistance for all three of them went up. So there's a direct relationship between resistance and length. As the length goes up, the resistance goes up. The longer the line was, the greater the resistance. This applies to electrical conductors as well, like electrical wires. If the wire is too long, the resistance gets too high. And you might say, well, what's such a big deal? Why does it matter if you have high resistance with a long wire? Remember, in Ohm's law, which is current equals V over R, if your resistance is really high because your line is really long, the current is really low. So let me give you an example of that, a true everyday life example. My first house I bought was in Richfield. And Richfield is an inner ring suburb built in the 50s, and the electric power lines are all above ground because that was the technology at that time. So my block, these are lots. All the lots are exactly the same size. They're all square, perfectly square, not real creative back then, right? So this was my lot. And I had a huge, let's say this is my house right here. I had a huge maple tree in my backyard. There was a tornado storm that came through southern Minnesota and turned into just a high windstorm when it got to the Twin Cities, but it knocked off one big corner of this tree and knocked the power line. The power line ran along this backyard property line. Okay, this was a fence, right? It knocked down the power to like a 3 or 4 block radius around my house. So my neighbor, his name was Kevin, went and bought a generator to put in the back of his yard because everyone was out electricity and we didn't know how long it was going to be. So Kevin did that so that he could have 2 main appliances that he could run a wire to his house for his refrigerator and his standalone freezer. So I said, hey, Kevin, that's a great idea. Do you mind if I plug into your generator? And he said, sure. So I plugged in my refrigerator and my freezer. Well, our third neighbor over here, Chris, said, hey, can I do that too? And he said, yep, we have 2 more outlets. We could do that. So Chris was a little bit further away, so he had to use 2 extension cords in order just to get it to his house, to his refrigerator and freezer. Guess what happened? Chris's refrigerator and his freezer would not start. They wouldn't operate. There wasn't enough electric current because the resistance was too high. Why was the resistance too high? Because he was too far away, and the longer the line is, the more resistance there was. Now, I mentioned this in class once, and someone said, well, could he have gotten a thicker extension cord? And he probably could have gone to Home Depot and bought an industrial or commercial grade extension cord, which would have been thicker. 6 millimeters is thicker, has less resistance for that length. If you go here, there's less resistance in a thick one than there is in a thin one. And so a thick one would have maybe compensated for that. It might have lowered this resistance, increased enough current in order for the motor in his refrigerator and his freezer to start up and operate. Okay? So so the other relationship then I just referred to is the thickness. The thicker you get, in other words, the 6 millimeter wide line, the lower the resistance. The thinner it is, the higher resistance. So the relationship there is as thickness increases, then resistance goes down. So an increase in thickness means a decrease in resistance, as you can see and interpret from that graph here. Okay? Let me give you an example about that. I won't go into as much detail, but if any of you are into car stereo systems or sound systems in general, you may have heard of somebody that's going to really trick out their car, their whatever, and put a really nice sound system in it, right? And they may put 500 watt speakers in the back of their car, or a really big subwoofer in the back of their car. You know, they really like the bass effect, right? Well, if you want to have 500 watts of sound to your stereo, what we learned, let me get a different color here. What we learned is in the videos is that power equals current times voltage. This is watts, 500 watt speaker. You're limited to a 12 volt battery. So how many amps of current, how much current do we need to deliver 500 watts to your speaker? Well, there's a lot. It's like 30 something watts or 30 something amps times 12 to get you 500 watts. Okay, that's a lot of current. How are we going to get that much current from a 12 volt battery to your 500 watt speaker if we want to deliver 500 watts of quality to that speaker? And the way we do that is we have really, really, really thick speaker wire. Some speaker wire companies are called, one of them is called Monster Cable. The thickness of that speaker wire is really thick, maybe the size, the thickness of your pinky. That's a pretty thick wire. Well, that means if it's thicker, there's less resistance. If there's less resistance, there's more current. If there's more current, then we can maybe deliver maximum watts to that stereo system, to that speaker. So if you pay for 500 watts, you want to get 500 watts of quality out of that speaker. And the way you accomplish that is having really thick wire. So speaker wires, you may notice, if you look at speaker wires, sometimes they're really thick and bulky, and that's the reason why. You want to lower the resistance so that you can draw maximum current. So that student that mentioned, could my neighbor Chris have gotten a thicker wire to lower the resistance? That's what they were thinking, okay? Because the lower the thickness, the higher, or the higher the thickness, the thicker the wire, the lower the resistance. Therefore, it can carry and draw more current to that device. Okay? So that's just a little bit of the review. Now, somewhat related to this right here, this is that same equation that we're using in that electric bill assignment that I introduced to you yesterday. Okay? Again, Xcel Energy cares when this becomes 1,000 watts. Which is why we take that watt number and we divide it by 1,000 to get it into kilowatts. Okay, but you're going to take the current, the amps, multiplied by the voltage to get your watts. You find the current on the device, on the label, on the packaging, on whatever. You know this is 120 volts. This is just a little review from yesterday. So we have to find this number. If we can find this number easily because it's a 40 watt light bulb, etc., then we can take 40 watts divided by 120 and that will give us the current. So we can fill in that current number even if it's not known to us. Okay? So lastly, let me just draw a little example here. I have two light bulbs. I have a 100 watt light bulb and a 40 watt light bulb. If I were to crack the glass off of this light bulb, off of these light bulbs, what would you notice different about the filament of each of these bulbs? What would be different? How would they look different? What do you think? 100 watts. What do you know about a 100-watt bulb? Well, it's brighter, right? Why is it brighter? I don't know. Why do you think? Why would a 100-watt bulb be brighter than a 40-watt bulb? Well, we just learned it. The filament that's inside the bulb of a 100-watt bulb is thicker than a 40-watt bulb. Higher thickness, lower resistance. Lower resistance means more current, and more current means a brighter bulb. It's the amount of current flowing through the bulb that's going to determine how much light is given off, how bright that bulb is going to be. So if it's a brighter bulb, you know it's going to have a thicker filament, and this one's going to have a thin filament. A thin filament has high resistance. High resistance has low current, and low current is not going to produce much light. It's not very bright. Okay? So this lab, coming back to this lab, this is called Lead Lines Lab. It's a very simple, crude lab. Crude in the sense that there's very little equipment to it. It's just that index card and a multimeter that we use to measure the resistance. When we're measuring resistance with a multimeter, we call it a ohm meter. You could call it a resistance meter, but resistance is measured in ohms. Ohms, right? Symbol is omega. So then we call it an ohm meter. If we're going to measure amps of current, we call it a ammeter. If we're going to measure voltage, we call it a voltmeter. But we have meters in lab that are multiple purposes, so we call it a multimeter. It's either an ohm meter or an ammeter or a voltmeter, depending on what we're using to measure. And all of these lessons that we learned out of this, that example with the generator and the length of the wires and the thickness of speaker wires, all of that, the brightness of light bulbs, all of that can be learned from just that simple, very elementary, very basic lab of an index card and putting graphite on it. Graphite is a conductor, so it will allow current to go through it or not, depending on how thin it is or long it is. Okay? Just a quick note, I'm putting a discussion board on each day. I may put just one general discussion board per chapter as we go forward. I'm not 100% sure of your view from it, the functionality from you. My intent is that you could post a question on that discussion board and anybody can chime in on, oh yeah, I found out where that question is. Or what is he talking about with this worksheet? I don't know where the worksheet is. Or you all can chime in and help each other in case I don't see it right away. But anyways, that discussion board, feel free if you have questions for me, if you don't have time to come to the office hours, but you want to throw in a question, I will answer that and everyone will benefit from it. That's the intent anyway. So there's a discussion board from yesterday. There's a discussion board on today. So feel free to use that and chime in and let me know how I could be doing things better. I'm not, this is my first go around with this distance learning too. So let me know what could be better, what maybe that will help, just having that discussion board. So let me know. Okay. Have a good day reviewing. Get your work done. Get your worksheet done. Get your workbook stuff done. And test tomorrow from 9:30 to 3:30. Again, it's not on Lockdown Browser. So, if you need to use your book, you need to use your notes, whatever, feel free. It's kind of like a glorified worksheet, if you will. Should be scoring quite high on these exams. So it's not on Lockdown Browser. Okay. Do well. Stay in touch. I have office hours today if you need to stop in and see me face to face. All right. Take care.